Hi friends, in this video we are going to discuss about Unit 2 syllabus of operating system. In this video we will see what are the important concepts and questions for operating system exams, final exam. So let's start our discussion here. So look at the syllabus once. It is starting with the process, CPU scheduling, process state, process control block, thread, process scheduling queues and schedulers, context switching, and preemptive scheduling, dispatcher, and scheduling criteria. It is it is an interesting unit, and you don't feel bored in this unit too. So there are some diagrams you need to practice. I will tell you the important ones you need to remember. So let's see one by one in this process. Second portion also you see process coordination, critical section problems and synchronization, semaphores and classical problems of synchronizations and monitor also there. See here process. What is a process? What is a process? We have seen in our class also. Process is a program under execution. A program under execution. Process is a program under execution. Right? Process is a program under execution. Okay. So you need to remember this definition. These keywords are important. A running instance of computer system. It is an independent. This consists of some memory, code, data, and some system resources. Okay. See the layout of the process in the system. This is the layout of process. What all are things here? 0 is the low level and max is the highest level. This is the size and some stack, memory, heap, and data, and some text also. This is the layout. If when you are writing definition and all, writing definition for process, you also write this diagram. Remember these words, keywords here. There is a stack on the top, heap, data, and text. These three. Okay. This arrows also means it is extendable. Okay. Next one, very important. This is very important question. I am saying here as a very important question. You need to remember. What is this question? Process state diagram. Process state diagram. Okay. In the exam, you may find the question like explain process state diagram. Okay. If you see that question in that exam, so you start writing the definition of the process. First write the definition of process. Okay. And mention the what are the states of the process. So here new state, and then terminated state, ready, running, and waiting. There are 5 states. Mention the states one by one and write 1 or 2 lines about the each state. New is the state when process enters the system, enters into the system, and when the process is waiting for the CPU, CPU is available at the running state. At running state, only CPU available to that process. Okay. So then come to the ready state, saying that I am ready to get executed by the, I am ready to meet the CPU. I am ready to meet the CPU. So staying at the ready code. It is new state means bomb state, and ready means we are waiting for the CPU. When CPU available, freely available, then that process can go and get executed by the CPU. If completed, then terminate that process. Otherwise, if some event, IO event, input output event, go to the waiting state, waiting state. After completion of waiting state, again coming to the ready state, not directly going to the running state, by going to the ready state. See, born, new state, coming to the ready, going to the, see, I am writing here, first one, new, okay, second, ready, third one, running, and next one, waiting. Okay, so I am mentioning the numbers also. Okay, you remember this order: new, ready, running, intermediate, and waiting. This, what is this diagram? Process state diagram. What is this diagram? Process state diagram. So this is a very important question. You write the definition for the process and make this diagram with the 5 states. How many states? 5 states: new, ready, running, waiting, and then terminate. There are 5 states. Okay. Fifth one, terminated. Terminated state. Okay. So next, look at the process control block. Process control block. It is an information about specific process. Each process has one PCB, process control block. Every process has one process control block. What this block contains? This block contains some details about there's some description about the process. See, the process PCB contains process ID, PCB contains process state, PCB contains process program counter, CPU registers, and memory management and IO information, and some accountable. See, there is a diagram also. So you make this diagram. Okay. Process state, process number, program counter, memory limits, and open files. You make this simple diagram. If you see a question about process control block in the exam, okay. Process ID means simply the ID for each process. Each process has some ID. in the operating system. Process state. What is the state? States, there are five states. Okay, you have seen in the last question. So what is the state in ready state, whether it is in ready state or blocked state? Blocked means waiting. Program counter. So what is the next instruction to be executed? What is the next instruction to be executed by the CPU? That instruction will be stored in the that information. What is the next instruction? That information stored in the process program counter. CPU registers. What CPU registers are storing at that moment? They also store IO information. These details are available in the process control block. Process control block. Okay. Next one is threads. What are the threads? Threads are the smallest units of a process, and they represent an individual execution path within a process. Okay. Unlike separate processes, threads within the same process share the memory. Okay. And system resources. They can share the resources. Look at the, oh, this is also process. Okay, I need to change this diagram. I will change this diagram in the website also. We should get here the thread diagram. Okay. Next one, scheduling queues. Scheduling queues. What are the different types of queues in the operating system? See, job queue, ready queue. Ready state, you know. So there, ready queue. Job queue at the new state, blocked queue at the waiting state, suspended and terminated. These are the queues. Terminated means terminated. Okay, completed queues. See here. So what are the queues in the computer? First one is job queue. Second one ready queue, block queue, suspended and terminated. Okay. About the threads also, you just remember the definition of the thread. Threads are the smallest units of a process. Okay, they share resources among them. So these are the scheduling queues. You write this diagram also. You mention what are the queues available in the system. Okay, here it is not process, it should be queues. Okay. Next, scheduler. How many types of schedulers are there? There are only three schedulers are there. One, two, three. There are three schedulers are there. Okay. First one is the long-term scheduler. Second, short-term scheduler. Long-term scheduler also called as job scheduler. Short-term scheduler also called as CPU scheduler. The medium-term scheduler is the third one. What long-term scheduler do, or what long-term scheduler does? Select a process from job queue. Okay, select a process from the job queue. Selects a process from the job queue. Okay, let's go to the next. Let's go to the second one, a short-term scheduler. What? this selects process from, you remember these words, right? Okay, here it is selecting what is this job queue. Okay, job queue here ready queue. Okay, and what is the third one here? Medium term scheduler, medium term scheduler. Okay, so when you suspend a process and if you want to resume after some time, that usually done by the medium, that is taken care by the medium term schedulers. Suspend and resume. When you suspend some process and you resume. So remember the words suspend and resume. Okay. Next one, context switch. Context switching. So when you are stopping one process in the middle and starting another process, when you are stopping that process, you need to save the details of that process. That is context switching. When you are stopping some process, when you are stopping some running process, or when you are suspending that process and giving chance for another process under CPU. So the process you are suspending or stopping temporarily, that should be saved properly. See here, there are two processes P0 and P1. Two processes are there. Okay. Save the state in PCB, right? Save the state in PCB process control block. After some time, what it is reloading the state from PCB. This is the need for PCB. Okay, you understand? So interrupt, save the state into, when you are stopping this one P1. So when you are stopping this one and are going to stop the P1, so save that state. And when you want to run the P0, so reload that one. If you want to run P1, load that one. If you want to run P0, so then load PCB 0, right? This is the context switching. Saving saving P0 to give chance for P1. Here saving P1, saving P1 to give chance for P0, right? This is the context switching. You can read more details from this passage, right? Next one, preemptive scheduling. Preemptive scheduling. What is preemptive scheduling? Is a type of scheduling where interrupting one process, one running process, and giving the chance to the another important process. That is called preemptive scheduling. So I'm repeating again. Interrupting some process, interrupting some process or some running process and giving the chance to other to run. Okay, that is preemptive scheduling. Preemptive means interrupting. Interrupt means stopping temporarily. Okay, interrupting that process temporarily and giving chance for another. So in normal, if it is not preemptive, so when process is running, after completion of the process, the next, suppose process 0 and 1 are there. Process 0 is running. If you want to run the process 1, so you need to wait till the completion of process 0. After completion of process 0, process 1 will start. Okay. So that is a traditional method. But in the preemptive scheduling, before the completion of the process 0, before the completion of process 0, we can stop that temporarily and we can give chance for P1. That is preemptive scheduling. Before completion of P0, we can stop temporarily and we can give, after completion of P1, again we can bring back that, again we can bring back P0. Okay, that is the idea. So next one is dispatch. What it is dispatching? Dispatcher is a program. What it is doing? See, performs context switching during the scheduling process. Responsible for saving the current process context, unloading the context of the, saving the context, unloading the context when the process coming for execution. Okay, that is the dispatcher. See in this diagram dispatch. So here it is diagram for dispatcher. Okay, wait for 1 minute. Okay, dispatcher, right? Mm, it is not process. No, 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 no. Where we are now, where is topic 9. Topic 9. It is dispatcher. Okay. Next one, scheduling criteria. So see here, process burst time. Some keywords are here. You need to understand this also. Process burst time, priority queue, deadline, and waiting time. What is turnaround time? What is the burst time? Burst time means time required for process to execute under CPU. Okay, total time required for process to be executed by the CPU. Priority. So priority start with the 0, priority 1, priority 2, priority 3. So priority 0 gets the first chance. Priority 1, the process with the priority 1 gets the chance in the order 2. Priority 3 process gets in the order 3. Okay. Priority should be less in number. Okay. Preference will be given for 0 and then 1, 2, like that it goes. Deadline, certain process we give deadline. Waiting time, how much is the waiting time. So when we are running multiple programs, multiple processes at a time under one CPU. So when one process is running, other process need to wait. How much is the waiting time for each process? We have seen these examples also in the class, right? Turnaround time. So it takes, it is a total time, waiting time plus burst time, any other time, whatever the time, all together we call as turnaround time. So when we are entering into the college, when we are leaving at the college at 5 o'clock, this is the total. Suppose when we are coming at 12 o'clock and leaving at 5 o'clock, that is the turnaround time. That is the 5 hour turnaround time. Process enter the system, we note down the time. Process leaving the system, we note down the time. The time between the start time and the entering time and leaving time is the turnaround time. Okay. Next, scheduling algorithms. Scheduling algorithms. So we see one by one what are the scheduling algorithms. First come, first serve. Whatever the process enters comes in the first. Suppose when we are taking some tickets in the railway reservation counter. So if we are in the queue, the one who comes first in the queue will be given the ticket first, right? That is the order. First come. Whoever comes in the first will be taken care of first. Okay. That is the idea under the first come, first serve algorithm. Second one, shortest job. See the name here. By looking at the name, you can write the answer. Shortest job next. Shortest job first. Another name. It has two names, right? Shortest job first. So the logic is the same here, both of these, in these both of these. Okay. Shortest. You take the shortest job first. Suppose P1 requires 5. P0 requires 10 units of time. I am saying 10 seconds, 5 seconds, P2 2 seconds. So we need to execute P2 first. Okay, we need to execute P2 first, and then we give chance to the which one? 5 P1, because it is its requirement is less than the P0, like that. Shortest job will be given first priority, like that. Okay. Next one, a round robin. In this round robin, there is a keyword called time slice. You remember this keyword, okay? That is called as time quantum. Each process in the ready queue will be given chance according to the time quantum. Suppose time quantum is suppose time quantum is 1 second. Suppose time quantum is 1 second. P1, P0, P1, P2 are there. 1 second will be given for P0, P1 and P2. In the first round, we give In the first round, it is round. See, round, the keyword. In the first round, we give 1 second to each process. Okay. In the second round, we give again 1 second each process. Like this, we make different rounds until the completion of each and every process in the system. Okay. Next, priority scheduling. Priority scheduling, we give priority to each process, and the highest priority will be executed in the system in the first. Okay, the first process which is getting executed is the process which is having highest priority, like zero priority is the highest priority, will be executed first in the system. Priority preemptive. Priority preemptive means priority preemptive means suppose P1 is running, uh, a process with the priority 1 is running, started, and again another process which is having the higher priority than the current process. The process with the priority 0 has entered. So we need to stop this one. When the higher priority process enters, we need to stop the lower priority task. 0 is the higher priority, and 1 is the lower priority. So we need to start, and we will give the chance for the process which is having higher priority. Okay, that is preemptive. Stopping something and giving chance to the another. Remember, preemptive means stopping something temporarily and giving chance to the another. Okay. Multi queue. These things also you remember, but these four or five, 1, 2, 3, 4, 5. You remember, you need to study. You can give them this multi-queue scheduling and multi-level queue scheduling. You can give it as a choice, right? I just added into this uh, notes, but you can leave this portion. At least you write 5 algorithms. That's enough. Next, we have process synchronization. So what it is doing, deals with the coordination and communication between the multiple processes. Okay. Next, critical section problem. What is this critical section problem saying? If this problem arises when in the current concurrent programming. Okay. It refers to the situation where multiple threads share the common resource. Here, the important thing is only one process can execute in its critical section at a time. Only one process should be in the critical section at a time. So, multiple processes are competing to enter the critical section. Only one process should be given the entry. Okay, suppose this is the critical section. Okay, suppose this is the critical section. You want to P0, P1, P2, multiple process. We will give only one process the chance to enter the after exit of the first one, we give the chance to the second one. That is the logic here. Synchronization hardware. So what it is saying, instructions barrier operator support. Synchronization of hardware. This I don't know. I need to study more. Next one, you It is also not important for synchronization of hardware. It is not important for exams. I did not prepare for that one. Next one is semaphore. Semaphores are the synchronization primitives used to coordinate the access to the shared resources. Semaphores are like signals in a road, traffic signals, like we see, right? 60 seconds, 30 seconds signal we see, green light, red light, yellow light. These are the signals. For what these signals are important? To coordinate the access to the in the on the road. Signals are important for coordination of vehicles on the road. Here, coordination is required for the processes, threads in the system. That's why semaphores we use. It has two states, wait state and signal state. Wait state, signal state. In the wait state, it decreases the value of the semaphore. You remember? Also remember, signal operation increases the value of semaphore. Okay. Semaphore is the integer variable. So when there is a wait operation, it decreases the semaphore value. When there is a signal operation, it increases the semaphore value. Okay. Monitor. Monitors also does the same thing like synchronization. Synchronization is a coordination, creating the environment of coordination. Allowing only one process to enter the monitor at a time. Next, classical problems of synchronization. Dining philosophers problem. Here, some number of philosophers sitting on a dining table for eating and thinking. Philosophers usually think and they also need to eat the food, otherwise they die, right? Some rice they given and a single chopstick. One spoon is given between the two people. Like that, there is a spoon between every two persons. Like that, thinking and eating are the two tasks. So that is the idea. What is the number of uh, spoons are not sufficient for eating. There is a one spoon between each pair of philosophers. So that is the problem. So next one, producer and consumer. There should be a balance. Suppose you are buying some pens. So if producer is producing more number of pens, and if there are no buyers, that is a problem, right? First problem is producer is producing more and there are no buyers. And the second problem you see, like there are too many buyers but no producer. That is also problem. That there should be coordination. Readers, writers. So if you are writing something, other hand readers should be there. If you are reading here, someone has to write. That coordination should be there. And these are the important one. These three you remember. Other things are not in your syllabus also. These three you remember. Dining philosopher's problem and producer consumer problem, readers writer. If you have time, you can go through these problems also. These are what these are called classic synchronization problems, classic problems of synchronization.